Okay, question 5 for the, I believe this one will just be BC. This is not the question 5 AB for 2024 free response question of AP Calc. Okay, so we have a table given here. The function f is twice differentiable. Um, I'm not sure if it's going to come up, but if it's twice differentiable, just remember that. Sometimes it's really nice if they're trying to get you to write something about maybe like the mean value theorem, but um, we'll see how it goes. So the function f is twice differentiable for all x with f of 0 equal to 0, so there's an initial condition. Values of f prime, the derivative of f, are given in the table for selected values of x. So when x is greater than 0, the function h is defined given here. Find the value of h prime of pi, show the work that leads to your answer. Not sure if it's going to show up, but that looks like a formula that everyone should know if you're taking BC Calc. I'm gonna. Okay, in any case, so find the values of h prime. So let's find what h prime of x is first. So that's what I see here when I see h prime. Well, let's find out what h prime of x is. So that's going to be the derivative of my expression given here. So the derivative from 0 to x of the square root of 1 plus f prime of t squared dt. This is probably a bit too explicit. I'm probably showing way too much work than I might need to, but in any case, if I'm taking the derivative of this by the fundamental theorem of calculus, I mean, they're inverse. They're inverse operations essentially. So h prime of x will be equal to the square root of 1 plus f prime of x squared, just like that. Of course, you would also multiply by the derivative of this right here, which would just be 1. But okay, so if that's h prime of x, let's find h prime of pi. So that would be the square root of 1 plus f prime of pi squared. And if we look at our table, we do have f prime of pi. That would be equal to 6, so we get the square root of 1 plus 6 squared, which would be equal to the square root of 1 plus 36, which would be the square root of 37. Okay, I think that's, so show the work that leads to your answer, find the value, there you go. Um, Here's B. What information does the integral from 0 to pi, okay, yeah, so there you go. So this right here, this formula given here, so the integral of the square root of 1 plus your function, the derivative of your function squared dx. This is the formula for the length of a curve over an interval. So what information does this give me about the graph of f? That's an important part about the graph of f. So it gives the length of the curve it gives me the length of the graph of f. Make sure you stay over the interval. So it gives the length of the graph of f over the interval um, from 0 to pi. I think it's very important that you put that there. From 0 to pi, that's what you put. You can also say over the interval of x equals 0 to x equals pi. You could probably say something like that, but as long as you state the interval, I think this is important. I would imagine that you would miss a point if you didn't state over the specified interval. Okay, alright, just make sure I got everything there. Use Euler's method. Yes, they like using Euler's methods on some free response questions. Starting with x equals 0, with two steps of equal size to approximate f of 2 pi, show the computations that lead to your answer. So usually how I teach Euler's method So when I set up my table, I'll have a column for f, I'll have a column for y, and then I'll have a column for dy dx times by delta x plus y. I kind of set up like this, might not be best notation, but so starting at x equals 0, we're trying to approximate 2 pi, so that's going to be our end x value with two steps of equal size. So to get from there to there in equal steps, the next step would have to be pi. So here to here, so that means delta x. So delta x is equal to pi, and then pi. And f of 0 is equal to 0, so that's our initial condition right here. So dy dx, of course, is going to be, maybe I'll just write this as f prime of x instead. So f prime of x rather than dy dx. And then I can just go ahead and change this right here to be pi. And then whatever my y value is, that's what I'm going to put in there. So f prime of 0. So I'm going to fill out this part right here. Essentially, I'm taking these values right here, I'm plugging them in as needed right here. So x is 0, f prime of 0, that's going to be multiplied by pi plus whatever value y I have here, so plus 0. F of f prime of 0, that's from the table, so that's going to be 5 times by pi plus 0. So that right there is my next value of y that I'm going to put in here. And now I'll use these values and I'll plug them in to the spots here. And whatever output I get here, that will be, essentially that's just going to be my answer. So f prime of pi times by pi plus 5 pi. So that's going to be equal to f prime of pi, which was 6 times by pi plus 5 pi, and that's equal to 11 pi. So, and then I'd probably write it out. I wouldn't leave it like that. So I would say f of 2 pi is equal to 11 pi. I guess if we want to be a little bit more technical, we would say we'd approximate it because we are using Euler's method. So use Euler's method starting with x equals 0 with two steps of equal size to approximate f of 2 pi. So f of 2 pi is approximately 11 pi. Okay. And this last part right here, so find the integral from t plus 5 cosine of t over 4 dt. Show the work that leads to your answer. I'm not really sure what that has to do with the problem, but okay. The function twice the differential for all x, f of 0 is equal to 0. Values of f prime, the derivative of f are given. Huh. Well, for me, when I'm looking at this, I see this integral. I see two different functions of t right here, and this is a linear function. This is a trig function, of course, with cosine. I think that's just screaming. That's screaming integration by parts. So I'm gonna let u be equal to t plus 5. Typically, in these situations right here, where you have algebraic, like a polynomial of sorts, multiplied by something like that's cyclical, that has cyclical derivatives and antiderivatives, meaning cosine or sine or e to the x, those derivatives and antiderivatives are cyclical. They keep repeating themselves. It's usually better to put this right here as dv and the polynomial as u, so u dv. So I'll say u is equal to this right here. I'll let dv be equal to cosine of t over 4 times by dt, and du will be equal to just dt. The derivative of t is just 1 dt, so there you go. And then v will be equal to so you would want sine of t over 4 times by 4 because of the chain rule. Again, you can differentiate this just to make sure that you get the same thing. So sine, derivative of sine is cosine. Derivative of the inside would be 1/4, so I had to divide this by 4. Those would cancel, leaving me with just a coefficient of 1 here. So that checks out. So, and then just remember, so the integral of u dv is equal to uv minus the integral of v du. So I'm just filling out, I just want to fill out this part right now. So my integral is going to be equal to u times v. So it's going to be this times by this. So I'll do t plus 5 times by, I'll put the 4 out here, and then so I'll put 4 here. I'll put sine of t over 4. So again, I'm just multiplying u and v together. That's these two multiplied together. Then I'm going to subtract the integral of v times by du. So that's just going to be 4 sine of t over 4 dt. And then that's going to be minus, that's going to be plus, because the antiderivative of sine would be negative cosine, and it's already negative outside there, so that would be cosine of t over 4. I would again have to multiply by 4 for the chain rule, so that would be 16. So I have 4t plus 5 sine of t divided by 4. Okay, let me just make sure that this is right. So if I take the derivative of cosine, that's going to be negative sine, and then multiply by 1/4, so then that would reduce to 4. So, okay, this right here should be my integral, the solution to my integral. So I'll just say this right here, the integral of t plus 5 cosine of t over 4 dt is equal to that, right? Oh, plus c, never forget your constant. Okay, and that should be everything for part 5.